Have you ever wondered why input is so crucial in Java programming? Well, it's the avenue through which your program interacts with the outside world, allowing users to feed data into it. Imagine having a program that can't take any user input. It would be like having a conversation where only one person is allowed to speak. Not very effective, right? In this exploration, we'll be covering several key aspects of Java input. We'll start with initialization, the process of preparing data before execution. Then we'll move on to parameters, which come into play at the time of execution. We'll also unpack the concept of packages and tread into the realm of input streams, with a special focus on the scanner class. Further on, we'll discuss the various types of errors that can occur during execution and compilation. And finally, we'll take a look at the different types of comments you can use in your code. Stay tuned as we dive into the world of Java input. Let's begin with initialization, the process of assigning a value before the execution of the program. In the world of Java, initialization is like setting up your chessboard before you start the game. Without it, your pieces, or in this case your variables, simply won't know where to stand. Consider this. You have a variable named score. Before your game begins, you want score to be 0. So you initialize it by writing int score equal sign 0. Here int is the type of variable, score is the name of the variable, and 0 is the value you're assigning to it. This is a simple example of initialization in Java. Now, why is initialization important? Well, it ensures that your variables have a defined state from the get-go. It helps to prevent errors, provides control over the program, and enhances readability. So, always remember, initialization is your first step in Java programming. Now that we know about initialization, let's move on to parameters. Parameters are essentially variables that allow us to pass information or data into methods in Java. They are declared in the method's parentheses when defining it, and they act as placeholders until the method is called with actual values. For instance, if we have a method that adds 2 numbers, those numbers would be our parameters. Consider a simple add method which takes 2 integers as parameters. When we call this method, we'll provide 2 actual values and our method will return their sum. The beauty of parameters lies in their ability to make our methods more versatile. With parameters, we can reuse the same method with different data, which makes our code cleaner, more efficient, and easier to maintain. Parameters thus allow us to make our programs more flexible and dynamic. They're an integral part of Java, and understanding them is key to mastering the language. Up next, we're going to explore packages and input streams in Java. Let's start with packages. In Java, a package is a namespace that organizes a set of related classes and interfaces. Think of it as a folder in a file directory. We use packages to avoid name conflicts and to write better maintainable code. Packages are divided into 2 categories: built-in packages and user-defined packages. So, whether you're dealing with strings, files, or network connections, there's a package to help you out. Now let's dive into input streams, a key component of Java's robust I/O framework. Input streams help us read data from various sources like a file, an array, a network connection, or the console. But how do we read data from the user during the execution of a program? The answer is the scanner class. The scanner class is a part of the Java util package. It breaks the input into tokens using a delimiter, which is whitespace by default. It provides various methods to read and pass various primitive values. Here's a quick rundown of some of the methods of the scanner class. Next short reads the next token of the input as a short. Next int and next long read the next token as an integer and long respectively. Next float and next double are used to read the next token of the input as a float and double respectively. Next finds and returns the next complete token from the scanner. Next line advances the scanner past the current line and returns the input that was skipped. Next to charat 0 reads the next token of the input as a string and returns the first character of the string. These methods make it easy to handle different types of input. and ensure your program can interact smoothly with the user. Packages and input streams, therefore, play a vital role in organizing and handling data in Java. Let's now turn our attention to the different types of errors you might encounter in Java. These errors are like potholes on your programming journey, but don't worry, we have your back. Let's dive right in. First on our list are syntax errors. These are the most common culprits and arise from violating the rules of Java language syntax. Think of it like trying to bake a cake but forgetting the baking powder. The recipe or syntax is off and the cake or program won't rise. For example, missing a semicolon at the end of a statement or forgetting a closing bracket. Java's compiler is good at catching these errors, allowing you to fix them before your program runs. Next, we have runtime errors. These occur when your program is running and something goes wrong. Imagine this: you're enjoying that cake you baked, but suddenly you bite into an eggshell. That's a runtime error. It's an unexpected event disrupting the program. A common example is trying to access an array element that doesn't exist. The program compiles just fine, but it crashes when you run it. Finally, we have logical errors. These are the trickiest bugs to hunt down. Picture this: you followed your cake recipe to the letter, but it came out tasting like a loaf of bread. That's a logical error. Your program runs, there are no syntax errors, but the output isn't what you expected. For example, using the wrong variable in a calculation. Your program can't catch these mistakes for you. You'll need to do some detective work to find them. Now that we've identified these errors, how do we deal with them? For syntax and runtime errors, the compiler and runtime system provide error messages. Pay attention to these. They're your first clue. Logical errors, though, require a keen eye for detail. This is where debugging and testing your code comes into play. In the end, remember that every mistake is an opportunity to learn. Understanding these errors will help you debug your programs more effectively. Finally, let's discuss the types of comments in Java. Comments are like the secret sauce to a well-cooked program. They're not seen by the machine, but they make a world of difference to the programmers who read and debug the code. In Java, we have two types of comments. Firstly, we have single-line comments. As the name suggests, these span only one line and are denoted by two forward slashes. For instance, // this is a single-line comment. Secondly, we have multi-line comments. These can span multiple lines and are enclosed within / and */. For example, per inch. So, whether you're leaving a brief note or explaining a complex piece of code, comments are your best friend. So always remember to comment your code. It makes your program easier to understand and debug. Let's recap what we've learned today. We began our journey with the concept of initialization, the process of assigning a value to a variable before the program execution. This is an essential step in Java programming as it sets the initial stage for our program. We then moved on to parameters, which are values passed to a method at the time of execution. Parameters give us the flexibility to manipulate data and alter the behavior of our program, making them an indispensable part of Java programming. Next, we delved into packages and input streams. Packages are Java's way of grouping related classes and interfaces, making our code more manageable and secure. On the other hand, input streams, particularly the scanner class, allow us to accept user input during the execution of our program. We explored various methods of the scanner class, including next short, next int, next long, next float, next double, next line, and next charat 0, each allowing us to input different types of data. Following this, we discussed the different types of errors that we might encounter during the compilation and execution of our program. Syntax errors, runtime errors, and logical errors each have their unique characteristics, and understanding these can save us a lot of debugging time. Finally, we looked at the types of comments in Java. Single-line comments, denoted by two forward slashes, and multi-line comments, enclosed within are an essential part of coding. Comments provide context and explanation for our code, making it easier for others and ourselves to understand the logic behind our program. Through our exploration of these topics, we have gained a comprehensive understanding of input in Java. Remember, practice is key in mastering these concepts. So don't hesitate to experiment and apply these concepts in your coding journey. With these concepts in your toolkit, you're well on your way to becoming a proficient Java programmer.